One of the basic human capabilities that we have is we can move around and perform physical activities. So I can lift things, I can walk, I can sit, I can stand up. So people started to make machines mimic this basic task, and that led to the field of robotics. And this is not a new field. It came in the early 1960s and 1970s. To that, the one thing we humans have is similarly, we humans have one more ability, that we can see things, right? And intelligent behavior is we can not only see things, we can interpret the environment. If I see things, I can detect what is that object. So this led to the field of something known as computer vision. So computer vision is where we take images or the video files, we try to identify the objects in it. Earlier versions, we used to detect one or two objects in those images or maybe the video files, but a pattern highlighted in green. That is to recognize patterns and learn from it. That field has emerged to very large extent, and nowadays we can detect multiple objects in real time. Best example is self-driving cars. I'm not talking about the medical field, because that advancement has happened in some other field. The machine which has learned from this data will be able to identify the data, right? So this is the training phase, that is the testing phase. So this type of learning is similar to your classroom teaching, where a teacher teaches the student with something and gives a test and asks the question. So this we call it as supervised learning. And one more thing is there, unsupervised learning, wherein I will just give the data to my model, right? But I'm not telling the machine what is this, maybe a basketball, football, or a baseball. But I'm just giving the data, but I'm not telling that what is this. So this is a data. You identify some pattern for it and group them into different clusters. So your machine has unlabeled data. It sees some pattern in it based on some algorithm, and it segregates the data into different parts. So this is the second part of learning. Last part is reinforced learning, where the system learns through events. Your system tries to do some action. It may yield positive impact or negative impact. Suppose if I want to play a game of this robot reaching that diamond, if it takes this path, yes, positive feedback. If it comes here, positive feedback. If it comes here, there's a fire. So this robot will get a negative feedback and it will trace back. Yes, I did something wrong. I should not repeat it again. This is more predominant in, say, suppose the rover sent to the Mars, wherein they have to find the path to the unknown place. They can use the reinforced learning. Why I took up this basic is, among these three major learning paths, medical field is predominantly dependent on AI in healthcare, is predominantly dependent on supervised learning. Because medical field, the healthcare is a field wherein I cannot try more of unsupervised or reinforced learning. Because everything is critical here. I cannot tell the machine, okay, try this something on the patient, learn from it. If something happens bad or some catastrophic things happen, you retract back and again try it. That cannot happen in the medical field. So the majority of the work wherein AI can fit into the medical field is supervised learning, where the machine has to be trained on the real-time data with labeled data with supervision. It learns from it and then acts accordingly, right? Because in software field, these generative models can generate a new code for a given scenario. If I say generate a code, generate a software for so and so requirement, within a fraction of minutes that code will be ready, that software will be ready. 50% of the software field, I mean the developers may lose their jobs in another 5 years. But that is not the case in healthcare. Because complete taking over by AI in healthcare is not possible. But that will complement the doctors. So, best example is if I give a CT scan or a X-ray or something to the machine and ask it to identify a disease, maybe a cancer or a degenerate or something, the machine will be able to do it. Right? This we say it as classifying or detecting. So using the medical images, the machines, pre-trained machines, can diagnose and let you know whether it is normal or abnormal, or where that abnormality is present in the images. But all said and done, training has to be done before with the data set. The machine can give you the output based on the data it has been trained. Right? So the accuracy of that model, of that AI model, depends on the type of data you have trained that model. And another application. So this is, maybe there are many products already available, and many of the scanning centers and hospitals have already adopted this. Next is the remote monitoring and wearable devices. This is the latest trend that is coming. Smart watches, the smart rings, smart glasses, maybe the patches, something. So these gadgets can monitor a human's pattern, features, and give real-time feedback on maybe the disease maybe that is present, or else a warning that so and so things can happen.
And also, a lot of AI started coming, whether it's Alexa or Siri or many other products which we use in a day in and day out. They're all AI technically, but we are not using healthcare ecosystem. And this person is called the godfather of neural networks. His name is Geoffrey Hinton. In 2016, he made a remark that we should stop training radiologists henceforth. In the next 5 years or maximum 10 years, there will be no need for radiologists across the world. And still we are there. I am a radiologist person. So still I am working. That means this has not become a reality. So what was expected was, probably our future radiologists will be something like this. A machine giving the entire answer saying, okay, this is your diagnosis. But this has not become a reality.
Students, when they work, how we made them work is work with collaboratively with either engineering students or with startups. Because as I was trying to tell you, we are domain experts, we are specialists in the subject, but we are not technical experts. We need not know how to code, we should know how to apply this project. So our students develop these tools, collaborate. For example, the first product is developed in collaboration with ST and JSSSTU, that is the STC Engineering College, in which the mammogram related breast cancer detection is automated. The next product is on TB, tuberculosis, in which it can say whether it is tuberculosis positive or negative, and also we added one feature on this. It also is trying to predict whether it is drug resistance or drug sensitive tuberculosis. It's a big thing. Although what I am saying when says we may not be very successful in our tools, because a good tool needs very good data, and the data we are feeding in is very minimal data. So these tools may not be great, but the thing is, what we are trying to do is, just as this seminar will awaken all of you that AI is coming, these will awaken our students how to use them. That is the whole concept in which we are doing it. Similarly, we have clinical decision support system. So once what usually now happens is, you send me a CT scan, I just report it and say, okay, there is brain hemorrhage, and I send it back to you. But what the future is, it should act like a comprehensive doctor. It should act like, okay, there is a brain hemorrhage, there is this midline shift, so the best next line of management is you should do surgery or you should conservatively manage, and this is the
best treatment option available according to this guideline. This guideline that is called as clinical decision support system. That is a comprehensive tool which incorporates everything put together. That's what the future should be looking towards at. And also, there's one more project which we have completed is on osteoarthritis detection. Similarly, many other products are also ready. And then we look into dermatology. There also AI is, image AI as a bane. It's a boon. Just make sure how you use it. Human in the loop, as was mentioned earlier also. Make sure you use it for your judgment and not for your entire decision making process. You use it to understand the whole process, then finally you make your own decision. This is the best way to make the decision. Thank you very much.
And my dear colleagues, I don't want to be before you for a long time, but at the same time I cannot go back without expressing some remarks as a president. It was a wonderful talk. And what is the take-home message? Just I will conclude the take-home message of both the speakers. At the outset, I thank both of them who have given a wonderful talk on AI implication in healthcare. See, we are all 70s doctors, especially me. As Dr. Vikram Patil said, we know the stethoscope and only percussion, but I can confidently tell you, we were treating better than all of you. We were enjoying the thrill of clinical medicine. We were enjoying. So that's of course support. So all these things, AI is complementary to the human brain. Nothing is equivalent to human brain. And one very important complementing remarks of Dr. Aditya for our medical profession is that AI can never replace doctors like in other fields. So therefore don't worry, there will be a demand for doctors. That's one very important message we have to take. So in all other fields, AI can replace. It can remove people from employment, never with medical profession. So that is one important take-home message an expert has given. The second most important is, as told by both of them, the data. The machine learning wonderfully explained. That Aditya has wonderfully explained what is the types of machine learning and how the machine learns. So therefore, the brain child of human being AI, you have to feed a data. See the limitation of AI. So nowadays we have to know the merits and limitations. So that is what is lacking in our young brains. So we should also know the limitation, merit, and when to use it. So the most important limitation of AI as well as India is concerned, the non-availability of the data, the perfect data, because of various environmental variations, because various lifestyle variations, and remember, man's mind is the most mysterious thing in the universe. There is nothing equivalent to man, both in intelligence and in the extreme of worst also. So the human brain is too extreme. And remember, more than that, there is Atma is there, which personalizes each individual. Which personalizes each individual. So therefore the data, keeping all other factors constant, the mind differs, the Atma differs. You may not believe in Atma. The Atma means the personal identification. The iris of two people, the palmar arches of two people, the foot impression, the thumb impression, palmar arch. Personal identification is specific. That specifies there is a unique Atma in individual which makes each individual different. So therefore, because of this variation, very difficult to get even in Western countries in a closed environment, a data which is 100% can be applied. And there are about 10,000 diseases. If you go, how many diseases are there? There are about 10,000 diseases, described diseases about. But on them, if you sort out, at least there are about 150 diseases which are common in the world. Of course, in India, if you know 50 diseases, you can be an expert, super specialist. Only 50 diseases. So therefore, it is why I am telling all these things. The most important observation of both of them is data. The machine works on data. So collection of data, standardization of data is very, very important, which may not be unique, which may not be that easy. So therefore, artificial intelligence in healthcare industry to apply is not 100%. For interpretation, again, you are needed. So therefore, this is the take-home message, and maybe in a few years, maybe down the line, 1 or 2 decades, so the artificial intelligence definitely in the management, I think it is going to take a very important role in the healthcare, the management. So, and quick decisions, differential diagnosis. So, the quick decisions and the accuracy and quick decisions, maybe it is useful and it could be a complementary in the healthcare. So therefore, we have to update our knowledge. These upcoming things, in especially diagnostics. As Dr. Patil said, the AI is going to replace the deficiency of specialists, super specialists in the field. Very difficult to get super specialist even in Mysore. So how can you get a super specialist in Saligama, Nanjangud and Mandya? So therefore, the most important implication of AI is replacement of super specialists, which is the order of the day, which is the demand of the day, and we are unable to produce so much of super
for his guidance, inspiration and leadership in making this academic event possible. Thank you, sir.